Welcome back. It is now time for episode 22. We're going to introduce either. So I've shown maybe quite a few times now. Either is the other binary data type that we can probably deal with. So I'm Reed Evans. I'm on Twitter at ReedNEvans. Let's look at what either actually is. So I mentioned it was binary. So if we look at it, we can call something a right of foo. We could also call something a left of foo. So basically either takes two type parameters, and one of the values is what it is on the right case. Another value is what it is on the left case. Those can be different types. So in other words, I could actually do a right of foo bar here, and I could do a left. The left case could still be foo. That would be perfectly fine. The kind of idea here is that the right value, in other words, it's what's called right biased. So the concept being that if you have something in an either right, that's kind of like the maybe just, and an either left is kind of like maybe nothing, but we get to supply additional information there. So when we do things like map's not going to touch the left side of either of this disjunction is what you could call it too. So map's not going to touch that. Bind's really not going to touch it. It's going to focus only on if it's a right. So what can we do with some of these things? Let's look at some examples. So one obvious way to deal with or place to use this is with some sort of validation. So we have this function here called location. It's going to take a city and a state, and assuming city and state are both not null, then we're going to return a right, and we're going to just basically package those up into an object. And if either of the city or the state are null, then we're going to return the left. So what does that look like? Well, if we pass Knoxville, Tennessee, then we get a right of that, and all is good. But if we were to pass null for the state, then we would get an either left from this return, saying that both city and state are required. One of the other things we can do, so that basically is just going to make sure that a location is a valid location for us, that the properties are there. So then what can we do? Well, let's try another one. Let's say from a business standpoint, we want the state to be Tn. So we got a state as Tn function, and it's going to take a location, and it's going to return either. Left case is going to be a string, and the right case is going to be a location again. And so if the state is Tn, then we're going to return the right of the value that passed in. If the state is not Tn, then we're going to return a left and let the user know that the state must be Tn. So if we were to do state is Tn and pass an object that had state equals ny, then the state must be Tn. And if obviously we had Tn here, then we would get an either right, state is Tn. We can also do some things like capitalize the state, so using object assign in here. So given a location, we'll return you another location. So what we want to do is we want to be able to compose all these things together to show you how either is both a functor and a monad. And so the way we're going to do that is we're going to have another function called process location. And this process location is just going to compose up three functions. So the first function that it's going to compose is this location. That's how we create our locations. And location takes a tuple of city and state. And then after we create that location, we're going to map to capitalize the state. We're going to map, because if we look at the function definition for capitalized state, it takes a location and returns a location. And what we saw was that with a functor, that's the shape that ends up fitting very nicely. So we're going to map the capitalized state. If you look at state as Tn, why is state as Tn different than capitalized state? Why do we chain here and map here? Well, it's very simple. Capitalized state takes a location and returns a location. State as Tn takes a location and it nests that, it returns an either string or a location. And because we're going from just a regular value here, just a regular location, to a location that's nested inside this context, we want to use chain. And as we've seen, because either is a monad, then we can chain, and because it's a functor, we can map. So what does all this end up doing for us? This defines what it means to create a location in our application that we're building up here. So we could unit test if you wanted to on the status TN, on the capitalized state, on any of these things really. All of them would be trivial to be able to test because we're writing very small pure functions and composing them together here using the either. So what does the calling code for that look like? Well, if we were to process the location of Knoxville, Tennessee, then we're going to get a write of a city of Knoxville and the state. You see the state was capitalized TN because we mapped that location through the capitalized state. And that ends up working fine. What if we pass a location that doesn't have a state of TN? Well, we get an either left. So the entirety of this function returns a left of state must be TN. So what does that tell us? That tells us that the location was fine. We passed a city and a state. We got to the map of capitalized state, and we said, sure, we can do that. And the reason we're mapping here is because location returns an either. So we want to deal with just the right case of the either, so we map, because capitalized state knows about a location. And our either here is either left of a string or right of a location. So this map allows us to deal with only the case where the either is a right and we get the location. And then we can chain status TN. Well, what we find is that status TN is where it failed because the result of all of this is state must be TN. And in this case, we're seeing that matches up with the fact that state is TN. So that didn't work there. But there's another place that we could fail. What if we passed null for both or either or whatever? Well, now we're getting both city and state are required. You see, we're still getting a value here. We didn't throw an exception. We didn't do anything else crazy. We still have a left that we could continue chaining over. We have an either that we could continue chaining over. It just so happens that it failed in the very first simple thing that all we had to do was to create this location. All we had to do here was not pass a null value for one of these two parameters, and it could have gotten past that. In this case, it didn't even get past that. So this capitalized state never got run because the implementation for map only deals with an either in the right position. Or the implementation of functor for either says that it's only going to map, and it'll only apply this function if the value it receives is a right. And because this never ran, chain is very, very similar. It's going to be right biased too. So this returned a left, and because this returned a left, we do nothing here and we do nothing here. So if you were to think about this as a branching logic, we've got an if-else branch here. We've got nothing here. We're basically saying this is in the if case. And then this branches inside the if case to do another if-else. So what's pretty neat is that we're able to write very concise up and down code here by composing stuff. But we've got several different points of potentially branching logic. And the either is really good at that because the either has an if and an else kind of baked in because it's that binary type. Anyway, hope you enjoyed this. This has been an introduction to either. Hope we've seen how either is a functor, either is also a monad, and you can do some really neat things with this. As we get into applicatives, you'll see how we could actually start providing multiple error messages. So to basically say, hey, the state needs to be capitalized and a few other things, rather than just passing the one thing at a time here. So anyway, I hope you enjoyed it. I'm Reed Evans, episode 22, Introduction to Either.